In this lesson, you will learn about how a system at equilibrium responds to changes in temperature. Le Chatelier's principle states that a chemical system at equilibrium always works to restore equilibrium when it is stressed. To consider what happens to a system at equilibrium when temperature is changed, you must first consider the energetics of the reaction in question. If the forward reaction is exothermic, then the reverse reaction must be endothermic. Let's examine this hypothetical reaction where reactant A reacts with reactant B to produce product C and product D, with a change in heat of minus 75 kilojoules. This means that when the forward reaction occurs, 75 kilojoules of energy is released and 75 kilojoules is absorbed when the reverse reaction occurs. So an increase in temperature would mean that the endothermic reaction would be favored to remove the excess heat, therefore counteracting the imposed stress. Decreasing the temperature would cause the system to produce more energy, therefore the exothermic reaction would be favored. The dimerization of nitrogen dioxide to dinitrogen tetroxide is an exothermic reaction. Nitrogen dioxide is a brown gas, whereas dinitrogen tetroxide is colorless. What observations do you think can be made when the temperature is decreased? How about when the temperature is increased? Please pause the lesson to think about this and resume once you are done. A decrease in temperature favors the exothermic reaction, so more dinitrogen tetroxide is produced. Since it is a colorless gas, the mixture should appear paler. An increase in temperature favors the endothermic reaction, so more nitrogen dioxide is produced. The mixture should therefore appear darker brown. Addition of a catalyst does not affect the position of equilibrium as it increases the rate of both the forward and reverse reactions. It only quickens the attainment of equilibrium. Let's return to the example of you digging a hole and your friend refilling it while you dig. Imagine that you are both given much larger shovels. The size of the hole still remains constant, but with each dig or fill, more soil is removed or filled. In conclusion, when the temperature of a system at equilibrium is increased, the endothermic reaction is favored. When the temperature of a system at equilibrium is decreased, the exothermic reaction is favored. Adding a catalyst has no effect on the position of equilibrium.